Hi, welcome to Matcom. In this particular video, we will be discussing one question from NCERT Chemistry Class Plus 2, Chapter Solution, exercise number 2.5. This question is from the end of the chapter. There are some problems are there. From that, we have chosen one problem, that is exercise 2.5. The question is, a solution of glucose in water is labeled as 10% weight by weight. What would be the molality and mole fraction of each component in the solution? If the density of solution is 1.2 grams per milliliter, then what shall be the molarity of the solution? Okay. So, what the data is given that there is a solution of glucose in water. That means the solute is glucose and the solvent is water. It is 10 percentage weight by weight percentage. Weight percentage is or mass percentage is 10 percentage. So what you can understand, if the 10 percentage of or 10 percentage weight by weight of glucose solution means if you are taking 100 gram of solution, if you are taking 100 gram of solution, in that there will be 10 gram of glucose, 10 gram of glucose and 90 gram of water. 10 gram of glucose and 90 gram of water. In net, the weight is going to be 100 gram of solution. Why? Since the glucose is dissolved in water. Glucose in water. Okay, done. Then they have mentioned that what is the molality and mole fraction of the each component in the solution. If the density of the solution, they have given the density of the solution is given as 1.2 grams per milliliter. Density is given as 1.2 grams per milliliter. We know that if you want to calculate molality equal to number of moles of solute, divided by mass of solvent in kilogram. Mass of solvent in kilogram. If the mass of the solvent is expressed in gram, you need to multiply it by 1000 at the numerator, or in the denominator you need to divide it by 1000. So we need mass of the solvent in kilogram. We know the mass of the solvent, that is 90 gram. We need to convert into kilogram, but we don't know the number of moles of solute. Here glucose is dissolved in water, so the glucose is the solute and water is the solvent. Then if you want to calculate mole fraction, what is mole fraction? The mole fraction of glucose is equal to number of moles of glucose divided by number of moles of glucose plus number of moles of water. It is basically like fraction of number of moles of that particular particle with respect to total number of moles present in that particular system. Since we are having only two components, glucose and water, in the denominator only two components will be coming. So we need number of moles. We have the weight of the glucose is given. Usually when you're taking the systems, when weight of the glucose is given, we can write it as the weight of the glucose is equal to 10 grams. The weight of water in the system equal to 90 grams. If you are calculating the molecular mass of glucose, what is molecular mass of glucose? The glucose formula is C6H12O6. We know that one carbon is having the weight of 12. Now we have 6. So 12 into 6 plus hydrogen is 1. Therefore 12 into 1 plus we have the mass of oxygen is 16. So 16 into 6. So it is coming out to be 12 into 6. That is going to be 72 plus 12 into 1, that is 12, plus 16 into 6. 10 into 6 is 60. It is going to be 96. If you want 9 plus 1, 10. 10 plus 17. Here 2 plus 2, 4, 6. So it is going to be 180 grams per mole. So the molecular weight of glucose is 180 grams per mole. We know that the molecular mass of water is 118 grams per mole. How 18? 2 hydrogen is 2, oxygen is 16, 16 plus 2 equal to 18 grams per mole. Now, if we are having that particular data, we can calculate number of moles of glucose. Number of moles of glucose is equal to the weight of the glucose divided by molecular mass of glucose. How we can calculate number of moles? Number of moles is equal to given weight, or given mass by molecular mass. Molecular mass. So the weight of the glucose in this particular system is 10 divided by 180. Okay. This is nothing but equal to 1 by 180. This is equal to 0.0055 moles. The same way you can calculate the number of moles of water equal to the weight of water divided by molecular mass of water. So this is going to be 180 divided by, sorry, what is the weight of water? Weight of water is 90. 90. Molecular mass of water is 18. 90 divided by 18, that is equal to 5 moles. So we got number of moles. So since we are having that particular data, now we can calculate mole fraction of glucose. So the mole fraction of glucose is equal to mole fraction of glucose, number of moles of glucose. Number of moles of glucose is 0.055 divided by number of moles of glucose is 0.055 plus number of moles of water is 5. So when you add, you will get 0.055 divided by 5.055. Okay. When you simplify it or cancel it, you will get approximately it will be equal to, approximately it is equal to 0.01. Mole fraction of glucose will be 0.01. The mole fraction of water will be equal to, you need to understand one thing. If there is only two components, the sum of mole fraction will be equal to what? That means the mole fraction of glucose plus mole fraction of water is going to be 1. So if mole fraction of glucose is 0.01, mole fraction of water will be 1 minus 0.01. That will be equal to 0.99 moles. Sorry, mole fraction is not having a unit. 0.99 is going to be the mole fraction. Clear? So now we have calculated mole fraction. Now we can calculate molality. What is molality? Molality is number of moles of solute divided by volume of solute, sorry, mass of the solvent in kilogram. Number of moles of solute. How many moles of glucose is there? 0.055. Done. Divided by 0.0055 divided by what is the mass of the solvent? The mass of the solvent is in kilogram. That means 90 gram. If you want to multiply, convert to kilogram, you need to divide it by 1000. So it will become 0.055 divided by 90 into 1000. These two get cancelled up. So you will get 5.5 divided by 9. So when you simplify it, you will get 0.617. Unit of molality is mole letter M. So we have calculated molality. Now we need to calculate one more parameter, that is the molarity of the solution. The last part they are asking, molarity of the solution. So the molarity of a solution, or the molarity equal to number of moles of solute divided by volume of solution in liters. Volume of solution in liters. We have number of moles of solute. What is the number of moles of solute? That is 0.055 moles of glucose is there. But we don't know the volume of solution in liter. So for that particular purpose only, they have given you the density. What they have given? They have given that density of the solution is equal to 1.2 grams per milliliter. It is having 1.2 grams per milliliter. So what is density? Density is equal to mass by volume. Density is equal to mass by volume. We have the mass of the solution, we have the density, but we don't know the volume. So what we can say, the volume of the solution equal to the mass of the solution or the weight of the solution divided by density of the solution. What is the mass of the solution? Mass of the solution is, we have taken 100 gram of solution. Why? Because in the beginning, since they have given mass percentage, we have considered 100 gram of solution in which we have 10 gram of glucose and 90 gram of water. So the mass of the solution is 100 divided by density of the solution is 1.2. So this is grams per, here the unit is grams per ml. This unit is gram. Gram will cancel. Ml will go up. So what will you get? So why? When 100 divided by 1.2, you will get 83.33. What will be the unit? It will be ml. Why it is ml is coming? Because gram divided by gram by ml. So gram will cancel. Ml will go up. So the unit is going to be ml. So the volume of the solution is going to be ml. So if you want to calculate the molarity, molarity equal to number of moles of solute, that is 0.055 divided by volume of the solution. Volume of the solution, since it is in ml, that is 83.33. In order to convert to liter, you need to divide it by 1000. So you will get 0.055 into 1000 divided by 83.33. So it is going to be 0.67 molar. So the molality is 0.617 molal. Molarity is 0.67 molar. So it's a good question from the chapter of solution, because since they have been given the weight of the solution, volume of the solution directly, but they have given the density of the solution. From the density what they have given, we can calculate the volume of the solution and we can solve it. So this is the way in which you need to approach this kind of questions. They can give you any system by changing the value of density or percentage, but whatever it may be the system they are giving, the solution procedure will be same. I think explanation was clear to you. If you need any clarification or any further explanation is expected, do let me know in the comment section. Also, if you want to need any modifications or if you want to see a solution for any particular question that has been asked in the previous year examination, or even it is from the textbook, or even it is from any outsource, please give it in the comment section. I will solve and upload the particular specific video. As a token of gratitude, please like to this particular video. Please subscribe to this channel. Keep watching, keep learning. Thanks for watching.